That was my. That's an image that also shows the GeoPortal technology. Again, that allows to access a number of different repositories and to provide them and to provide access to them in a harmonized manner. The component that I was mentioning before, now tools actually will be also used in the context of BRISEIDE because it helps actually creating sort of virtual databases from existing repository. The idea being is that you connect different repositories into a sort of virtual database that then can be exposed as a service, as an OWS in a very easy manner. So that basically becomes very transparent to the user. You connect data and then these are stored and their metadata is then stored again, but it's all done in a transparent manner. So that makes life very easy for us when it comes to integrating all those repositories. And then the geo-browser that we have seen before. And the idea in terms of architecture, of course, is to create a service-oriented architecture, so make it interoperable and Scala. But again, in this case, Solar, the traditional Solar is not really enough. The idea is that we have to extend it to create a sort of decision support framework, because this is all what BRISEIDE is all about. And the scenario, if we want to see it in terms of actors, we will see on the one hand the general public, for instance, that will be available to access data through the geo browser, for instance, a specific map that might be created for public use, for public interest, and then operators accessing BRISEIDE through their technologies or through the geo browsers. So that's the general vision. And the idea is to provide a sort of layered view, starting from very low level, so data, then data access, then there is all the management of data, then on top of that, having the reasoning. That is so essential when it comes to civil protection, so make analysis and provide decision support. So from a slightly more technical perspective, the system is articulated in the standard three layers. So we have the data layers on the very bottom of it. Then we have the middleware. The idea is that we have a number of base services. With base services, we refer to them as, for instance, the standard OWS, WMS, WFS. You can think of them as a sort of base services. And then on top of them, we have the sort of high level or value-added services, as we refer to them in BRISEIDE. That means processing services, routing, sensor access, and the orchestration, which is essential, of course, to connect them all, to wire them up. All of them, or most of them, will be developed from a technical point of view as Java component, and they will be exposed through the server as such web services through a serverless component. I'm not detailing more of this because then it probably becomes too technical. The idea then again is that you can connect the functionalities to the system, as in this case the 3D geo-browser. So if we zoom into that lowest level that you've seen before, you might see something like that, basically different repositories for different pilots. And all of them will be wired up within the BRISEIDE pilot and then exposed onto the web. From sensor view, if you like, the idea is that then we connect all the sensors through the middleware and then they are made available in interoperable manner. This might require, for instance, using standards such as SOS, the standard sensor observation service from OGC. This is extremely important because if we look at what is happening right now, for instance, this is the example of the province of Trento. What is happening right now is that the different sensors which are deployed in the territory or over the region, that are collected, the information is collected and then sent to the central office. But then all of them are managed through a different piece of software. So basically what happens is that if something goes really bad, you have to rely on one single person being capable of using one single bit of software. And that means that basically if you have 10 different types of systems and sensors, then you end up with 10 different softwares and with 10 different operators being able to use them. And of course this doesn't make sense. So the idea is to make them interoperable and having everybody enabling everybody to have access to all those information, which is so critical. And a similar, slightly different feature, of course, could be made for, in the case of BRISEIDE. In this case, it's more articulated than what happens in Trento. But again, the idea is to provide BRISEIDE access to the existing data, so that again they can be accessed in this properly. If we zoom at the second level, which is the middleware, you will see something like that. I was mentioning before, there is a sort of a set of base level services. These include WFM, WMS, and so on and so forth. Then you have value-added services, for instance, change detection, thinking in a time-wise manner. So how a land cover might evolve across time. It requires a change detection technology. Another special temporal operators or routing services and so on. And then on top of everything, you have the service or orchestration level that basically makes it possible to create complex chains of processes and that can support fairly complex simulation. Again, that's probably even more detailed view, but you can see that all the bits and pieces are here. You have this part, this GeoServer part, then you have the ingestion that I was mentioning before, so the components that it's used to wire up all the different repository into a sort of virtual repository. Then you have the catalog, and then you have a set of pilot-driven components that requires all the spatial temporal features. If some of you is interested in the details of that, I'm very happy to discuss them on a one-to-one basis in this workshop. The idea of using WPS is very simple. For instance, in this case, let's suppose we need a buffering operation. You send to the server, the data set, and you ask the system to create a buffer, and then as a result, you get this back. And this can, of course, be extended to any sort of processing simulation, fairly complex processing simulation that you might have. And of course, the advantage is that, first of all, it becomes interoperable. Second of all, it becomes very scalable, because if you need more processing power, it's all on the server side, so it's very easy to scale up. And it becomes distributed, so that basically each single processing functionality could be distributed on different locations. And the very same approach will be used to wrap up existing technologies. For instance, I was mentioning before the example of this shear project, which has provided a very complex algorithm to simulate how fire propagates. In this case, what we will take the existing technology, the existing software, and we will wrap it so that it becomes basically interoperable. So from a software point of view, it's a very simple operation. But from the value-added point of view, it's very important because it makes it accessible in a standardized manner. When it comes to communication, we can think of the desktop application basically that speaks to the server container, and then the server container speaks to the application server. This is where all the business intelligence basically is located. And then an operator, for instance, using ArcGIS or whatever commercial technology, we just connect to the application service and operate at this level. So that's sort of communication-oriented overview of the system. And that's a mock-up of how we think the final system might look like. That's not the final system, of course. It's just to get your flavor of how this might look like. So you would probably have a 3D view at the center, and then a number of visualization kits that can be used to render some sorts of patterns or trends of information that you might need, plus some sort of panels with other information. This is just to get an idea of how integrated we imagine the system to be like when it will be running in 1 year, almost in 1 year. Okay, and these are just other examples of the technologies that is already existing As I was mentioning, the idea basically is that every single processing component becomes a black box with some inputs and some outputs. You don't need to know the details of it. What you need to know is what is this about, what needs as an input and what it produces an output. And then you just connect them all to create a sort of high level functionality. As simple as that. You've seen the video already. So now let me thank you all, and I leave the floor to Giuseppe.